Hello friends, today I will discuss about fault calculation for particular bus for single line to ground fault. So a system has been shown in this figure where a generator is connected by a generating transformer of delta star type and the rating of the generator and the transformer has been shown in this figure. So earlier video I have discussed about the same example, that is the three-phase symmetrical fault occur at point F, that is at 66 kV bus, and due to this what is the value of the fault current at point F or at 66 kV bus. So in this video I will discuss about the value of the fault current for 66 kV bus for single line to ground fault. So just like earlier video, the fault current should be calculated for single line to ground fault for pre-fault voltage at 66 kV bus is 70 kV. So we'll convert it to the per unit value at 66 kV bus, which will comes as 670 divided by 66, which is equal to 1.06 per unit. So just like earlier video, we have taken the base MVA as 100 MVA and we will convert all the positive sequence, negative sequence and zero sequence impedance of this equipment, different equipment to per unit quantity in 100 MVA base. So first for generator, the positive sequence impedance is 17.5%. So to its own base, that is own base is 75 MVA. So 200 MVA base, it will comes as G1 is equal to 0.175 into 100 divided by 75, which comes as 0.234 per unit. And for transformer, positive sequence impedance, negative sequence impedance and zero sequence impedance are all equal. That is the percentage impedance is given as 0.1 or 10% to its own base value, that is 75 MVA. We will convert it to common base, that is 100 MVA base, which comes as 0.133 per unit. So positive sequence network has been drawn. Here the source voltage will be there and the positive sequence component of the generator and positive sequence component of the transformer will be there. Now we'll draw the negative sequence network. The negative sequence impedance value for generator is 13.5%. So to convert it to 100 MVA base, we'll get the value of the negative sequence impedance, that is ZJ2, is equal to 0.135 into 100 divided by 75, which comes as 0.180 per unit. And negative sequence impedance of the transformer is 0.133 per unit. So for drawing the negative sequence network, there will be no source voltage, only negative sequence impedance in per unit of the generator and transformer will be there. And now we have to draw the zero sequence network. Since it is a delta star connected and star point is connected by means of the neutral grounding resistor and value of the resistor is 58 ohm. So the value of this zero sequence component of this resistor is Zn0 is equal to 3 into Zn, which comes as 174 ohm. Now since it is a delta star connected transformer and star point is grounded, so in fault in the star side of the transformer, that is the earth fault, if any earth fault occur in the star side of the transformer, this earth fault current will flow in the star side and also flow in the delta connected winding, but it will not flow in the line side of the delta side of the transformer. So in order to draw the zero sequence network, only in the transformer zero sequence impedance and zero sequence impedance of the neutral grounding resistor will be accounted for. So Zn0, that is the zero sequence component of the resistor is 174 ohm. So we'll convert it to per unit quantity and the value of the Z base, that is the base impedance at 66 kV is kV square by MVA, which comes as 66 square divided by 100 is equal to 43.6 ohm. So value of the zero sequence component of the NGR, that is neutral grounding resistor, is 174 divided by 43.6, which comes as 3.99 per unit. So we can draw the zero sequence network now. Since it is a single line to ground fault, the three component of the current, that is the positive sequence component of the current, is equal to negative sequence component of the current and equal to zero sequence component of the current, that is I1 is equal to I2 is equal to I0. So we'll calculate the value of the each component of the current, that is I1 is equal to I2 is equal to I0 equal to E divided by Z1 plus Z2 plus Z0. So I1 is equal to I2 is equal to I0 is equal to E divided by Z1 plus Z2 plus Z0. Here the value of the E is equal to the free fault voltage in per unit quantity, which is equal to 1.06 per unit. And value of the Z1 is equal to sum of the two sequence component or positive sequence component of the generator and the transformer, which comes as J.234 plus J.133 per unit. And Z2 is the sum of the negative sequence component of the generator and negative sequence component of the transformer, which is equal to J.180 plus J.133 per unit. And Z0 is the sum of the zero sequence component of the impedance of the transformer and the zero sequence component of the NGR, that is neutral grounding resistor, which is equal to 3.99 plus J.133 per unit. So which comes as Z1 plus Z2 plus Z0 comes as 3.99 plus J.833 per unit. So the value of the I1 plus I2 plus I0 comes as 0.255 minus J.052 per unit. So value of the fault current, which is IF is equal to IA. Let's consider the fault occur in the red phase. So value of the fault current, that is the at red phase, equal to 3 into I0, which is equal to 3 into 0.255 minus J.052, which is equal to 0.6765 minus J.156 per unit. Now the base current is equal to, that is the MVA base divided by root 3 into voltage base. Voltage base is 66 kV and base current comes as 100 into 10 to the power 3 divided by 1.732 into 166, which comes as 874.8 ampere. So value of the fault current in actual quantity comes as base current into per unit quantity of the fault current. Here the per unit quantity of the fault current is 0.765 minus J.156 per unit, or we can write as 0.7807 at an angle minus 11.52 per unit. So IF, that is the value of the fault current, comes as base current into fault current in per unit quantity, which comes as 683 at an angle minus 11.52 degree ampere. So this is how the single line to ground fault occur, the fault current can be calculated. So friends, if you like my video, then do subscribe my channel and also press bell button for notification of videos to be uploaded in future. Thank you for watching this video.